All right, this is how to subtract mixed numbers now. So we have a mixed number. Let's say it is 5 and 11/15. And we want to subtract or take away 2 and 1/3. All right, pretty simple. What you can do is immediately just subtract the whole numbers. 5 minus 2, because they're wholes, right? They're entire pieces. So 5 minus 2 will give you 3. Next, you're going to concentrate on the fractions. You know that to add or subtract fractions, you need common denominators. So I've got my 11/15 over here, and I'll keep it the same color. And I need my other fraction to be the same denominator. So what I have is I need some way to turn 1/3 into something over 15. Well, if you know your math facts, you'll know that 15 is a multiple of 3. And how do we get it? We multiply by 5. 3 times 5 will give you 15. And so what I do to the bottom, I can do to the top. 1 times 5 is 5. So now my new equation is 11/15 subtract 5/15. They have the same denominator, 15ths, or same pieces now. So now we can say, what's 11 pieces minus 5 pieces? And, well, that's simply 6 out of 15 pieces. And so my final answer will be 3 and 6/15. However, I recognize that both 6 and 15 have a common factor of 3. So I can divide by 3 and divide by 3. And so I can say it is going to be 3 and 6 divided by 3 is what? 2. 15 divided by 3 is 5. So your final answer is 3 and 2/5. All right, let's try another one. Let's say I had 6 and 1/4, and I want to take away 3 and 3/4. Well, most of the work is already done because I have common denominators, so I can get straight to it. First, I'm going to subtract the whole numbers. 6 minus 3 is 3 wholes. And then I need to do 1/4 minus 3/4, the fractions. So they have common denominators, so it's going to be 4. 1 minus 3, ooh, this is interesting. I've got a negative, and I can't have a negative here. So what I'm going to have to do is I'm going to have to figure out a way to make the 1/4 an equivalent fraction. So here's how I'm going to do that. I'm going to borrow actually from the 6. And here's what I mean. So as you know, the 6 represents, like, let's say it's fourths, right? So you have wholes or whole cakes that are separated into fourths. And you have 6 of those. Technically you have 7. And I'll show you why. 1, 2, 3, 4, 5, 6, right? So there's the 6 wholes. And then the 1/4 is here. There's the 1/4. So it's 6 wholes filled and 1/4. You can't take away 3 from 4. So what I'm going to have to do is I'm going to have to borrow 4 from one of the holes here. So what I mean is I'm going to split this up into fourths, right? So technically this is going to become a 5, right? 5 holes, 1, 2, 3, 4, 5. And then I'm going to add 4/4 to this 1/4. So really it's going to be 6 and 1/4 is going to be borrowed 5, right? That's the 5. And then what I've done is I've separated that whole that I borrowed into 4/4. I'm going to add it to the 1/4. So now it's literally 5 and 4 plus 1 is 5/4, right? And you can count that and literally see it. Ready? Here's 1, 2, 3, 4, 5/4. And so now what I can do is I can say, all right, 5 and 5/4 minus 3 and 3/4, just like borrowing. And so now I can do it. So I can do 5 minus 3 is 2. That takes care of that. 5/4 minus 3/4. 5 minus 3 is 2/4. And so I'm going to have 2 and 2/4, but I can divide by 2 because they have common factors. And I'm going to get 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So I'm going to get a total of 2 and 1/2. And just because I could literally turn one of these wholes into its parts and then use those parts to add to the one that did not have enough, the 1/4, and I made it 5 and 5/4, which is really the same thing.